Hello students, welcome to the next lecture on the differential equation. Based on your request, I will upload the today's lecture is on Legendre equations. I will tell you the brief idea. First of all, what is the lecture on the Legendre polynomials and what is the Legendre equations, features, motivations and many things. Myself Dr. Harish, you can follow and subscribe my YouTube channel where you can find the playlist of the ordinary differential equation, and you can see various lectures such as Frobenius methods, power series, CSR net, gate, examination papers, solutions and many more lecture available in this single playlist. Now, first of all, what is the motivation behind the Legendre equation? Imagine you are on the spherical world. So if you consider about the spherical world, all of you remember there are only two kind of the worlds on which we are trying to study the phenomena. One is called as a periodic and second is spherical. Fine. We all know whenever we are working on the periodic, we are working on the sine and cosine functions. Fine. However, whenever you are working on the spherical world, what could you imagine on this spherical world? First of all, definitely there will exist some gravitational force. Fine. Definitely there will exist some magnetic field, or you can call as an electric field and so on. So imagine you are studying the physical phenomena of the sphere, and the topic which we are included in the spherical worlds are gravitational potential of the earth, electric field, heat distributions, quantum mechanics of the atoms and many more topics. But if you look about all these topics very carefully, then every scientist who are working in these fields have come out the conclusion that all these topics have ended up the special kind of the differential equations which are defined in equation number 1, where lambda is my any parameter. Fine. Based on a particular value of the lambda, we can classify as a different nature of the differential equation. Scientists has found that for the specific value of the beta, the solution of the equation number 1 come out to be very special, beautiful polynomials, and that polynomials is called as the Legendre polynomials, and they are defined by the French mathematicians Andre Marie Legendre. What is a simple analog behind the Legendre equations or the Legendre polynomial? Imagine you are on the periodic world. Whenever you are thinking about the periodic world, which series you can imagine that? Definitely you are working on the Fourier series. That means any function fx you can write in terms of the linear combination of the cosine and the sin x. Cos of x plus b1 sin x, a2 cos 2x plus b2 sin 2x and so on. Any periodic function can be expanded in the terms of the sine and cosine function. What does it mean? That means you are working on the basis. What are the bases of the periodic function? Bases are my cos x and the sin x. That means cosine and sine are the form the basic in case of the periodic world. Similarly, if you look about the spherical world, and if you especially work on the interval -1, 1, then instead of writing as a cosine and the sine, we consider as a polynomials called as P0, P1, P2 and so on, and these Pn's are called as the Legendre polynomials. Fine. So if you compare them, if you look about the spherical worlds and the periodic world, in the periodic world, what are the bases? Bases are my cosine and the sine. However, in the spherical world, bases are my Legendre polynomial. So what does it mean? That means whenever you are working on the periodical phenomena, sine and cosine are my natural functions. On the other hand, whenever you are looking for the spherical phenomena, polynomials, specially called as the Legendre polynomials, are my natural functions, and that is the motivations to extend the periodic world to the spherical world. Now, if you look about the spheric, about the axis x, y and z, z on my north pole and these are the south pole, and any point on the sphere has a distance of r from the origin. It make an angle theta. Fine. Theta is my face angle. Fine. And what is the r? R is a radius. Fine. And clearly say, if you look about the x coordinate, fine, that is nothing but my r of cos theta. Fine. So if I code as a polar angle is my theta, radius is my 1, x lies between -1 to 1, then clearly say Legendre polynomials are depending upon the function x is equal to cos theta, and since the maximum and the minimum value of the cos theta is -1 to +1. Now once we can consider the very beautiful equations by choosing the specific value of the lambda. If I choose very specific value of the lambda, then it is called as the Legendre polynomials or Legendre equation. For example, if I consider the lambda is n into n plus 1, then the differential equation 1 is called as Legendre differential equation. Fine. Only whenever you consider the lambda is n into n plus 1 for any n belongs to the natural number. Clear? So for example, if you again look about this case, what is the x is equal to 0? Can you identify whether x is equal to 0 is an ordinary point or it is a singular point? You can clearly say at x is equal to 0, coefficient of the y double prime is my non-zero. Therefore, x is equal to 0 is my ordinary point. Fine. और ordinary point के लिए मैंने आपको example क्या दिया था? You can consider the road which is considered as a very smooth road. That means solution about the point x is equal to 0 behave a well-defined functions. For more details about the motivation of the smooth road, you can watch about my lecture called as concepts of the ordinary and the singular point. इसमें मैंने काफी real life example के साथ आपको explain करा है. On the other hand, if you consider the value of the x is plus minus 1, then clearly say the coefficient of the y double prime becomes my 0. Therefore, x is plus minus 1 is my singular point. So what is the meaning of the singular point? Singular point किसको कहते थे हम? जहां पे solution आपका disturbance हो जाए. That means at x is equal to plus minus 1, the solution disturb, मतलब solution well behave नहीं करेगा. तो अगर आप इस रोड वाली एग्जांपल में disturbance किसे कहोगे आप? Disturbance is when there is some obstacle at the point x is 1 or at the point x is -1, and that reason, that means the solution is not well behaved at the point -1 and the +1. Now, if I consider the particular value of the lambda, that is n into n plus 1, that we call as the Legendre equation. For each n, remember each, if you consider n is 1, you will get the solution of the differential equation, that is my polynomial. When you consider n is 2, again you will get the solution, that is called as a different solution than from the n is equal to 1, but it's still a polynomial, and so on. Corresponding to the each n, we will get a solution called as the polynomial solution, and that polynomial of the Legendre equation is called as the Legendre polynomial, and we denoted the Legendre polynomial is Pnx, where Pnx is called as the polynomial of the degree n. अगर यहाँ पे आपने n की वैल्यू 2 लिया है, then we consider as the polynomial of P2x. If you consider n is 1, fine, then we call as the solution is P1x, and so. Clear? And how we can find the solution? How we can find the solution? Corresponding to x is equal to 0, clearly say x is equal to 0 is my ordinary point. Fine. And once you can get the ordinary point, you can apply the power series method to get the solution. Fine. और इसका solution भी मैं आपको इस lecture series में explain करूंगा आपको. Fine. Corresponding to, if you take n is equal to 0, तो आपका differential equation क्या बन जाएगा? 1 minus x square y double prime minus 2xy prime is 0. And if you try to find the solution, you will get 1 is a required solution. If you consider n is 1, तो आपकी differential equation क्या बन जाएगी? 1 into 2, that will be 2y is equal to 0, and you can get the solution is p1 because n is equal to 1, and that solution is my x. Similarly, if you consider n is 2, you will get the another solution. If you consider n is 3, you will get the another solution, and so. Fine. These are the first few Legendre polynomials corresponding to the different value of the n. From all these Legendre polynomials, the first observation is, if you consider p1, then the polynomial has a degree 1. If you consider n is 2, the polynomial has a degree 2. The degree of the each polynomial of the pn is my n. Another observation you can obtain, whenever p of n, whenever n is even, the polynomial is also even. Fine. P of 2 is an even polynomial. P of 4 is an even polynomial. Even को कैसे check करते हो? Even and odd. If you substitute p, I will check whether p4 is an even or not. You can check for the p4 is fine. That is called as the even polynomial. On the other hand, if you consider the p3, that's the odd. Whenever n is my odd, then pn is my odd degree polynomial. Fine. You can see that's the odd function. Clearly say p3 is my odd function. They form the alternative. Even, odd, even, odd, even. The next one will be odd, and so on. So they form the alternative between the even and the odd functions. But the question arises is how we can generate these polynomials. एक तो मेथड है कि आप polynomial Legendre equation को solve करिए, but that is a very tedious process. How we can generate all these, like how we can compute the p5, how you can compute the p of 10. Fine. In order to generate these polynomials, we can define the generating formula called as the Rogers formula. The concept is a very simple. We can define corresponding to the different value of the n. इसका proof, इसके related examples मैं आपको separate lecture में दूंगा when I will try to explain you the concept of this formula. For example, if you take n is equal to 0, what will happen? P of 0x. 2 raised power 0 is 1, 0 factorial is 1, 0th derivative is 1. So that means P of 0 is my 1. If you consider n is 1, that will be 1 over 2 raised to power n. N is my 1. Fine. 1 factorial is my 1. First derivative of the x square minus 1. What is the first derivative? 2x. And if you cancel out that, that will be my x. Similarly, if you find n is equal to 2, if you substitute 2 raised to power 2 is 4 into 2 factorial. Second derivative of x square minus 1 square. If you find the second derivative and substitute the value, you will get the answer is half of 3x square minus 1. Similarly, if you take n is equal to 3 and so on, you will get the required constructive polynomials. If you draw the graph, clearly say p of naught is x constant, so that is my straight line. P of 1 is x, that is a passing through the origin, that is my parabola, and so on. Fine, it's a straight line, it's a passing through the origin, it's a parabola. Similarly, if you find the p3 of x, you can get the curves p3, p4, p5, and so on. Now, one of the most important property of this Legendre polynomial is orthogonality. We know in case of the periodic function, what is the periodic function orthogonality? When you taken the period from the 0 to 2 pi, sine of mx, sine of nx. What is the answer? It will be 0 whenever m is not equal to n, and it is my pi whenever m is equal to n. यही होता है आपके पास. Now similarly, instead of writing as a sine, similarly for the cosine, fine, it's a cosine, both are the same meaning. Instead of taken as a periodic phenomena, we consider on the spherical phenomena, pm into pn. ऑन द इंटरवल -1 to 1. -1 to 1 क्यों लिया है? बिकॉज -1 से 1 के बीच, -1 और +1 पे क्या था, वो सिंगुलर पॉइंट था. Whenever you consider the interval -1 to 1, the based on whether m is not equal to n, that will be 0, which is similar to the periodic word. On the other hand, whenever m is equal to n, then we can define it's a pnx whole square. Fine. Of dx, it will be defined as 2 over 2n plus 1. और इसका भी प्रूफ मैं इसके कोरस्पॉन्डिंग लेक्चर में आपको डिफाइन करूंगा. Another property, what is the geometrical thinking? If you consider two vector a, fine, let's say a is my x-axis, fine, b is my y-axis, and clearly say what is the dot product of the two vector, 1 comma 0, 0 comma 1, which is 0. If the dot product of the two vector is 0, that means a vector is perpendicular to the b vector. यही मीनिंग होता है ना orthogonal vectors. Fine. And we all know the orthogonal vectors implies independence. The same concept we can apply for the Legendre polynomials. Fine. That means Legendre polynomials are the orthogonal functions. If you consider the p naught, p1 and p2, that means if you consider p naught into p1, that will be 0. If you consider p naught into p2, that will be 0, and so on. And how you can prove that? You can see my function is -1 to 1, p naught into p1. So clearly say what is my p naught? P naught is 1, p1 is my x. If you substitute the value, you can see it's a x into dx, and if you integrate that, that will be 0. Similarly, if you consider the p2, that will be half 3x square minus 1. If you consider the p1 dot p2 from -1 to 1, again you will see it's my 0. Similarly, p naught and p2, and so on. So that implies once they are the orthogonal, that means you can easily write as a linear combinations of the polynomials. For example, any function fx which are defined from the -1 to +1, you can easily define as a linear combinations of the Legendre polynomials, c naught, c1 plus c2, c3, and so on, because pi's are my Legendre polynomials, and in the spherical world they form the basis. Fine. So as I mentioned, you can write just as a vector, you can write in the basis. So while corresponding the function, they are written as a Legendre basis. Why the Legendre polynomials are important? First of all, it has wider applications. It are widely used in the physics, engineering, mathematics, and so on. For example, whenever you are studying the gravitational field, electrostatistics, quantum mechanics, wave propagations, if you are the students of the physics, fine, look at these topics, fine, check about their calculation, you will get the Legendre polynomial as their solution. Similarly, if you are working on the signal processing, numerical, fine, FEM, fine, very useful once you are doing the research field, fine, then you will see the Legendre polynomial. On the other hand, whenever you are the students of the mathematics, if you look about the orthogonal function approximation theory, that is a part of the functional analysis, find spectral method of the differential equations, and many more lectures, all are correlated with the Legendre polynomials. So based on the special differential equation, what you have obtained, the solution of this differential equation 1 is always in the form of the polynomial, but based on the particular value of the n, we call as the Legendre polynomial. Fine. And the key factor is the polynomial, each of the polynomial pn, तो इसकी degree भी n होगी. If I consider the p2, then it must be of the degree 2, and they are orthogonal, they form a basic. Fine, it form the natural spherical coordinate problems, and few of them I have listed at these pi's, and that for that you can easily derive once we can form as the Rorschach's formula. मैं आपको इस पूरी लेक्चर सीरीज में हर पॉइंट जो हमने इसमें डिस्कस करा है एक एक करके सेपरेट वीडियो में एक्सप्लेन करूंगा. If you are really interested to learn more about the Legendre polynomials and its problem solving, let me know in the comment box. I will upload for you in a very simple manner. We will see the next lecture on the solutions of the Legendre equation, how that polynomials form from the differential equation. Till then, you can share this video with your friends, like and comment on the videos. Best of luck, students. Happy learning.